Hello, you are welcome to our SHS 3 Core Mathematics lesson brought to you by the Center for National Distance Learning and Open Schooling. My name is Lucy Asari Nelson. Today we begin with a new topic called matrices. Matrices is one addition that has been done for the examination syllabus. By the end of this lesson, you should be able to 1. Define a matrix. 2. Find the order of a matrix. 3. Recognize the types of matrices. And 4. Should be able to add and subtract matrices. When a large amount of numerical data has to be used, it is often convenient to arrange the numbers in the form of a rectangle called a matrix. Suppose that a nursery man offers collections of fruit trees in 3 different groups. The following table shows the name, each collection, and number of each type of tree included in it. So we can see this table where we have the collection. The collection include apple, pear, and mangoes, as well as oranges. And we also have type A, type B, type C. So on this table, for the first type of collection, that's collection A, we have 4 apples, 4 pears, 6 mangoes, and 7 oranges. For collection B, we have 5 apples, no pears, 5 mangoes, and 4 oranges. And then for collection C, we'll have 2 apples, 1 pear, 2 mangoes, and 9 oranges. After a time, the headings and the titles could be removed because those concerned with the packaging and collections would know what the various numbers meant. The table then could look like this, where we have the numbers 4467, 5054, 2129. The information has now been arranged in a matrix. That is, in an array of numbers. Therefore, a matrix is a collection of numbers arranged in a fixed number of rows and columns. Usually, the numbers are real numbers. Each number in the array is called an element or an entry. The numbers 4, 4, 6, 7 form a row. Similarly, the numbers 4, 5, 2 form a column. A matrix is always enclosed in curved brackets. The matrix we discussed earlier in the table has 3 rows and 4 columns. It is a matrix of order 3 by 4. The cross there is mentioned by, so we have 3 by 4. In defining the order of a matrix, the number of rows is always stated first, and then the number of columns follow. The matrix A is equal to 4, 5, negative 2, 4, 6, 0. This matrix has the order 3 by 2 because It has 3 rows and 2 columns. Let's take some examples. State the order of each of the following matrices. A, the matrix 3, 4. This matrix has order 1 by 2. So we say it's a 1 by 2 matrix. Good. B, negative 7, 0. This matrix has order 2 by 1. It is a 2 by 1 matrix. C, the matrix 1, 0, negative 2, 4, 6, negative 3. It is a 2 by 3 matrix. D, we have the matrix 2, 6, 1, 0, negative 1, 3. This matrix has the order 3 by 2. It has 3 rows and 2 columns. E, the matrix 6 is a 1 by 1 matrix. Good. Let's take another example. So example 2. Goals scored by 3 local football clubs, WAFA, Hearts, and Olympics in 3 weeks of play are as follows. So we have the array of numbers. We have WAFA, we have Hearts, we have Olympics. And then we have week 1, week 2, week 3. So the matrix that is coming out of that is 3, 2, 1, 4, 1, 0, and then 3, 3, 2. This matrix has 3 rows, 3 columns. The rows are 3, 2, 1, 4, 1, 0, and then 3, 3, 2. And the columns are 3, 4, 3, 2, 1, 3, and 1, 0, 2. Good. So now A, what is the order of this matrix? The order is 3 by 3. It has 3 rows and 3 columns. B, how many goals did Oli score in week 3? The answer is 2. C, what is the total number of goals for WAFA by week 3? The answer will be 3 plus 4 plus 3, which is equal to 10. Let's take example 3. Paula, George, and Francis have a choice to buy bars of chocolates from 2 shops M and N. This matrix shows the foods they bought and their quantities. So we have Paula, we have George, we have Francis, and we have shop M, shop N. The matrix is 7, 3, 6, 4, 4, 8. A, how many bars of chocolates did George buy in shop M? The answer is 6. Good. B, how many chocolates did Francis buy all together? The answer is 12. That is 4 plus 8. And then C, how many chocolates did they buy in shop N? In shop N, they bought 3 plus 4 plus 8, and that will give us 15. Good. Now let us look at the types of matrices. Some types of matrices are 1. A row matrix. A row matrix is a matrix having only one row. Example, the matrix 5, 7 is a row matrix. Another type is column matrix. This is a matrix having only one column. That is, the matrix 3, 4, 2 is a column matrix. 3. The null matrix. This is a matrix with all its elements being 0. Example of a null matrix is 0, 0, 0, 0. This matrix has the order 2 by 2. All its entries are zeros. Good. Let's take the fourth type. We have the square matrix. The square matrix is a matrix having the same number of rows as columns. Example, the matrix 2, 5, 0, 1 is a square matrix. We also have a type called the diagonal matrix. This is a square matrix in which all the elements are 0 except the diagonal. That is, the matrix 3, 0, 0, 5 is a diagonal matrix. I want you to note that the diagonal in a matrix always runs from the upper left to the lower right. Let's take another example of a diagonal matrix. The matrix 1, 0, 0, 0, 5, 0, 0, 0, 4 is a diagonal matrix. It has the order 3 by 3. Good. There is another type called the unit matrix. This is a matrix in which the diagonal elements are all ones. A unit matrix is usually denoted by the symbol I. That is, the 2 by 2 unit matrix is I is equal to 1, 0, 0, 1. I hope that is clear. Good. Now let's take a look at the algebra of matrices. I want us to do addition and subtraction of matrices. Two matrices can be added provided they have the same order. Addition is done by adding together the corresponding elements or entries of each of the two matrices. Example, the matrix 8, 9, 3, 6 plus the matrix 4, 5, 2, 0 will give us 8 plus 4, 9 plus 5, 3 plus 2, and then 6 plus 0. That is corresponding elements being added. When we simplify that, we will have 12, 14, 5, and 6. I hope that is clear. Good. Subtraction of matrices is done in a similar way, except that the corresponding elements are subtracted. That is, we have the matrix 10, 7, 4, 9 minus the matrix 4, 8, 6, 5. And that will be equal to 10 minus 4, 7 minus 8, 4 minus 6, and then 9 minus 5. We simplify this to get 6, negative 1, negative 2, 4. Great. Let us take some more examples. Express each of the following as a single matrix. A. The matrix negative 2, negative 16, 3, 3 plus the matrix 4, 15, 7, 4. B. The matrix 2, negative 4, 5, negative 5, 6, 9 minus the matrix negative 4, 2, 13, 4, 7, negative 2. C. The matrix 5, 4, negative 3, negative 3, 0, negative 7, 5, 3, negative 5, plus the matrix negative 4, 5, 7, 3, negative 10, 12, 6, 5, 9. 2. Given that 2x, y, 7, the matrix 2x, y, 7 plus the matrix 4y, negative 3, 2 is equal to the matrix x, 9, z, 9. Find the values of x, y, and z. Now let's take the solutions. We start with A. Remember, we said for us to be able to add any two matrices, they must have the same order. So we have the matrix negative 2, negative 16, 3, 3 plus the matrix 4, 15, 7, 4. Adding the corresponding elements, we will have negative 2 plus 4, negative 16 plus 15, 3 plus 7, and 3 plus 4. And we'll simplify that to get 2, negative 1, 10, 7 as our answer. Good. Let's take the solution of the second one. We have the matrix 2, negative 4, 5, negative 5, 6, 9 minus negative 4, 2, 13, 4, 7, negative 2. That will be equal to 2 minus negative 4, negative 4 minus 2, 5 minus 13, negative 5 minus 4, 6 minus 7, and then 9 minus negative 2. We'll simplify that to get 6, negative 6, negative 8 for the first row, and then negative 9, negative 1, and 11 for the second row. Therefore, the matrix is 6, negative 6, negative 8, negative 9, negative 1, 11. Good. We are taking the solution for the third one. We have the matrix 5, 4, negative 3, negative 3, 0, negative 7, 5, 3, negative 5, plus negative 4, 5, 7, 3, negative 10, 12, 6, 5, 9. We are going to add the corresponding elements. So that will be equal to 5 minus 4, 4 plus 5, negative 3 plus 7 for the first row. For the second row, we will have negative 3 plus 3, 0 minus 10, negative 7 plus 12. And for the third row, we have 5 plus 6, 3 plus 5, negative 5 plus 9. When we simplify that, we have the matrix 1, 9, 4, 0, negative 10, 5, 11, 8, 4. I hope you understand. Good. For the second question, we were given that 2x, y, 7, that is the matrix 2x, y, 7, plus the matrix 4y, negative 3, 2, is equal to the matrix x, 9, z, 9. And we are to find the values of x, y, and z. Remember, we have to add the corresponding elements. So we will have 2 plus 4, which is 6. Then for the other elements, we'll have x plus y. That forms the first row. We'll also have y minus 3. And then 7 plus 2 for the second row. When we simplify that, we'll have 6, x plus y, y minus 3, 9. Now, we want to simplify further. In matrices, we can always equate the corresponding values. So, we have 6 and x being corresponding. So 6 is equal to x. In other words, x is equal to 6. So that's our value for x. Again, we have x plus y is equal to 9. But we already have x as 6. So we'll place 6 in place of x, and that will give us 6 plus y is equal to 9. And so we have y is equal to 9 minus 6, which is equal to 3. So y is equal to 3. We also have y minus 3 to be equal to z. But we had y to be 3. That means 3 minus 3 is equal to z. And that will give us z to be 0. So z is equal to 0. I hope that is clear. In matrices, when matrices are equal, we can always equate the corresponding elements. Good. I hope you have followed the lesson until this point. We have to end it here. But before then, in this lesson, we have learned that a matrix is an array of numbers, and that each number in a matrix is called an element. We have also learned that the order of a matrix is defined as the number of rows by the number of columns. again that any matrix that has the same number of rows as it has columns is called a square matrix. We also learned that a unit matrix is a matrix in which the diagonal elements are all ones. Well, this brings us to the end of the first lesson on matrices. Join us again for the continuation of this topic in our next lesson. Until then, it's goodbye.